Hello everyone. This presentation is about one of the most popular Python library, Spacy. I will be talking about the key features and benefits for Spacy, its installation, etc. I will also walk you through the basic concepts of text processing using Spacy. Finally, I will end the presentation by addressing a few limitations of this library. Introduction of Spacy. Spacy is an open source library for advanced natural language processing in Python. It is designed to be fast, efficient, and easy to use, making it a popular choice for NLP tasks. Key features of Spacy. The library offers a wide range of features for processing text, including tokenization, part-of-speech tagging, dependency parsing, named entity recognition, and text classification. It also provides pre-trained models for various languages, which can be easily customized for specific tasks. Coming to the benefits of this library, the significance of Spacy lies in its ability to automate complex tasks that were previously time-consuming and required a lot of manual effort. Using Spacy, developers and researchers can efficiently process and analyze large amounts of text data, extract meaningful information from it, and gain insights that were not possible before. In addition to its speed and efficiency, Spacy's accuracy and performance are also impressive. It uses deep learning models and neural networks which have been trained on large amount of data to perform various NLP tasks. This makes it a reliable tool for text processing and analysis in multiple fields, including machine learning, data science, and artificial intelligence. Installation and setup of Spacy. Here are the steps to install and set up Spacy. First is install Spacy using pip. Then download a pre-trained model for the language we want to process. We can find the list of available models on the Spacy website. For example, to download the English model, run the following command. Once the model is downloaded, we can load it in your Python script using the following code. The last step is test the installation by running a simple script to process some text. For example, we can tokenize a sentence and print the tokens and their part-of-speech tags. We have now installed and set up Spacy in your Python environment. You can start using its various features to process and analyze text. Next is some basic concepts of text analysis using Spacy. Tokenization. Tokenization is the process of breaking down the text into individual words or tokens. In Spacy, we can tokenize a text by creating a doc object and iterating over its token objects. Next is stemming. Stemming is the process of reducing a word to its base form, which is often useful for text analysis. In Spacy, stemming is not provided out of the box, but we can use our other Python libraries like NLTK to perform stemming. Lemmatization. Lemmatization is the process of reducing a word to its base form, which is more accurate than stemming. In Spacy, we can lemmatize a word by accessing its lemma attribute. Here is an example. Now, stop words. Stop words are common words like the, a, and is that are often removed from text during analysis because they do not carry much meaning. In Spacy, we can access a list of stop words for a language by calling the stop words attribute of the language model. POS tagging. Part of speech tagging is the process of labeling each word in a sentence with its corresponding part of speech, such as noun, verb, adjective, adverb, etc. POS tagging is an important step in many NLP tasks and it helps to disambiguate the meaning of words and enables a computer to understand the structure of a sentence. In Spacy, we can perform POS tagging on a text by iterating over the token objects in a doc object and accessing their POS attribute. Next is named entity recognition. It is a process of identifying and classifying named entities in text such as people, organizations, locations, dates, etc. NIR is useful in extracting information from text as it can automatically identify important entities and their relationships, which can then be used for tasks such as information retrieval, question answering, and text summarization. Dependency parsing. Dependency parsing is the process of analyzing the grammatical structure of a sentence by identifying the relationship between words. In a dependency parsing parse tree, each word in the sentence is represented as a node, and the relationship between the words are represented as edges between the nodes. In Spacy, we can perform dependency parsing on a text by iterating over the token objects in a doc object and accessing their head and children attributes. The head attribute gives the parent node of the current token in the dependency parse tree, and the current attribute gives the child node of the current token. We can see an example here. Next is text classification. Text classification is the process of assigning categories or labels to a text based on its content. It is useful in various NLP applications such as sentiment analysis, spam detection, and topic classification. It works by training a machine learning model on a labeled dataset. Here are some basic steps for text classification. First, collect the label dataset, then preprocess the text, then train the machine learning model, evaluate the model, and finally use the model to classify new text. In Spacy, we can train a model using the text classifier component. The text categorizer is a neural network model that assigns probability to each category based on the content of the text. We need to provide a label dataset to train the text categorizer. After training, we need to evaluate the performance of the model. We can use various matrices such as accuracy, precision, and recall to evaluate the model. We can also use a confusion matrix to visualize the performance of the model. After visual evaluation, we can use the model to classify new text. Now, I will list out a few limitations of Spacy. First one is language support. Spacy supports a number of languages, but not all languages are supported. Currently, Spacy supports 18 languages, including English, German, Spanish, and French. If we need to work with a language that is not supported, we may need to look for alternative NLP libraries or consider training our own models. Next one is training data. To get the most out of Spacy's capabilities, we will need to train models on label data that is specific to our use case. However, collecting and labeling data can be time consuming and expensive. Additionally, the quality of our trained model will depend on the quality and quantity of our training data. Third one is customization. While Spacy provides a range of customizable components and options, there may be cases where we need more fine grained control over the NLP pipeline or need to customize specific components. In such cases, we may need to modify the Spacy source code or look for alternative libraries that provide more customization options. Fourth one is the performance. Spacy is a fast and efficient library, but it may not be suitable for extremely large datasets or real-time processing of streaming data. In such cases, we may need to look for alternative NLP libraries or consider using distributed computing frameworks like Apache Spark. The last limitation is user interface. While Spacy provides a comprehensive command line interface and API, it does not provide a graphical user interface for visualizing NLP pipelines or results. However, there are third party tools that can be used for this purpose, such as Displacy and SpacyViz. Spacy is a powerful and versatile tool for natural language processing in Python. Its speed, efficiency, accuracy, and performance makes it a reliable choice for text processing and analysis. It is widely used in various industries, including academia, research, and business. Here, I'm concluding the presentation. Thank you.